Alright guys, so the goals of this video, we're going to look into how to solve an initial value problem for a differential equation by parts. Alright, we're still going on that concept that, okay, we're trying U substitution. U substitution isn't working, and so we use a new method, which we've been calling integration by parts. So the goal is to look into really how can we find what the constant of integration is going to be if we integrate a certain diff EQ by parts, or integration by parts. So let's take a look at an example here. It says solve the initial value problem for the current differential equation. And our dy dx, our differential, is x times ln of x, and it says y equals -1 when x equals positive 1 here. Okay? And so let's take a look first and foremost. So we're going to be looking into finding the antiderivative, obviously, of x times the natural log of x. And so let's just go ahead and understand that the value of y is going to equal whatever the integral of x times the natural log of x dx for our differential is going to be. And so then we got to think to ourselves as to why are we looking into this thing. Well, let's think about this. Let's look at our possibilities for our u and our dv. And so remember our LIPIT acronym. The first concept is can we possibly use a natural log as your number one option? And think about it for a sec. Do you happen to know why we always want to try to focus on the natural log as being our first choice for u? Well, hopefully you're starting to realize that if you chose it for dv, taking the antiderivative of the natural log is not an easy thing, but taking the derivative of the natural log is actually quite simple. So let's go ahead and make u our natural log, and we'll make dv our value of x times dx. Alright, so now we've got our u and our dv. So we want to find du. Our du is that derivative of our natural log, and so du in this example is going to be 1 over x dx. And then we want to find the integral of x. We're just going to raise the power and divide by that power. So v is going to end up with just simply x squared over 2. Alright, so now I've got a lot of our pieces to our integral by parts. So let's go ahead and try to find out what all the different pieces are going to look like here. So I'm going to go ahead and change colors so we start separating some things on out a little bit. And so we want to go ahead and find u times v. Well, u times v would be the natural log of x times our x squared over 2. That is our u times our v. Now we're looking at the minus the integral of v times du. v times du. So let's go ahead and subtract the integral of x squared over 2 times 1 over x times dx. Don't forget that dx in there, guys. The differential makes a big deal. Maybe not so much in terms of the end result, but in the concepts and the application of it. Making sure that dx follows you with you is extremely important. But what do you notice about what's happened in that integral now? I noticed a nice little situation happening here is the fact that x and the squared can cancel out with one another. And so now you're just left with x over 2. And so when you're left with x over 2, you'll raise that power, so it'll be x squared over 4 when it's all said and done. So right now we are at x squared of the natural times the natural log of x over 2 minus, once again, I'm going to raise the power of x to the second, divide that by 2, being multiplied by the 2 that's already there, will give us x squared over 4. Okay? Let me, just so I don't skip through it completely. Where I got this from, guys, was we have this becoming x over 2. So the integral of x over 2 Well, I'm going to raise the power, which will be squared, and then there's already a 2 down there, so the 2 that I divide by has to stay in there as well. So that's where my x squared minus 4 comes from. And then, of course, now I have plus c. And the whole point of the initial value is to find out what that constant was. And so now it's our job that when y equals -1, is what the initial value told us, was y was -1, x equaled 1. And so in order to do, we need to move to the fact that, try to make this good, we have -1 is going to equal 1 times the natural log of x, 1 times the natural log of 1 over 2 minus 1 over 4 plus c. So in simplifying down, well, this becomes 0. Then we add the 1/4 on over, so the -1 plus 1/4, that'll give us -3 over 4. So c will equal -3 over 4 in the end. And then to finish up our problem, we will have x squared over 2 times the natural log of x minus x over 4 minus 3/4. And that is the value of our initial function there. All right. So let's give one a shot on your own. All right. Let's give one a shot on your own. Now disregard what I have written up there right now, guys. That's going to be for the next video. So kind of disregard the solving for the unknown integral at this moment in time. But as a way to practice an initial value problem, I want you guys to go ahead. I'm going to put initial value right here. Okay, initial value, and I apologize for the writing. I'm not really sure what ends up happening here on OneNote. Every once in a while it gets very boxy on me. So let's give this one a shot. Same concept. You have dy dx will be equal to x plus 2 times sine of x, and then this is going to be when y equals 2 and x equals 0. All right, give that one a shot on your own and see what you come on up with. And hopefully you can arrive at the answer of negative x plus 2 times the cosine of x plus sine x plus 4. Alright, that will be your final result. Double check and see if you're on the same page, and off to the next one.